This video is an extension of the structure of the heart video. So we're going to be using the heart that I constructed in that video to explain the cardiac cycle. And in order to explain the cardiac cycle, we need to define what diastolic and systolic mean. So let's start with the heart I constructed in the structure of the heart video, and we're going to make it beat again.
So you'll notice that your heart actually contracts like this. It goes dub dub lub dub lub dub lub dub. So your atriums contract, push blood into your ventricles contract and push blood out of the arteries. This time, watch the heart contract again, but this time notice what happens to our four valves. So you'll notice that as our atriums contract, the bicuspid and tricuspid valves will open. Meanwhile, the semilunar valves close. Then when the ventricles contract, the bicuspid and tricuspid will close, stopping that blood going back into the atriums, but meanwhile the semilunar valves will open, allowing blood to go into the arteries. So when we talk about the heart contracting, you might have heard of the two terms called systole and diastole. Now, they sound like confusing words, but they're fairly easy to work out. Systole means contraction, while diastole means relaxation. So if the atrium is contracting, it is under systole. So you would say atrial systole. If the atrium is relaxing, you would say atrial diastole. Now, same again for the ventricle. If the ventricle is contracting, you would say ventricular systole, and if it was relaxing, you would say ventricular diastole. So when the atrium is under systole, contracting, you need the ventricles to be under diastole to receive the blood. If both the atrium and ventricle contract at the same time, blood would be forced everywhere. So you need atrial systole, ventricular diastole to receive the blood. Then when you have ventricular systole, so contraction, you need atrial diastole. So as the ventricular systole happens, it pushes blood out of the heart. Meanwhile, the atriums are relaxing to fill up with the next round of blood. So then it becomes a nice rhythm of the atriums receive blood as the ventricles pump out the blood. Then the blood is pumped into the ventricles again. They receive the blood. The ventricles contract, push blood out of the heart. The atriums receive more blood, and then we have a nice rhythm. You don't want to be waiting around for the atriums to fill up before you can receive. You need it to be a nice rhythm. Now that I've made the heart with coffee beans, I'm now going to use Play-Doh as my representation of blood. So I've got some red Play-Doh to represent oxygenated blood, and I've got some blue Play-Doh to represent deoxygenated blood. So let's watch the Play-Doh, which is now the blood in my heart, move through the heart. So what do we mean by deoxygenated and oxygenated blood? Well, deoxygenated means blood that has low oxygen in it, as in hence the D, while oxygenated blood has a fresh, good supply of oxygen, hence the name oxygenated. So you'll get oxygenated blood when it's coming from the lungs, because that's the job of the lungs, is to put oxygen into the blood. So if it's the pulmonary vein coming back to the heart, because it's a vein, and pulmonary means lungs, if it's coming in the pulmonary vein back into the heart, well, it must be oxygenated because it's just come from the lungs. If it's just come from the body, then you have to assume it's deoxygenated because the body has used all that oxygen up. If it's going to the lungs, then you have to assume it's deoxygenated because it needs to go to the lungs to pick up oxygen. And then it comes back via the pulmonary vein, oxygenated, and then you've got your pulmonary, your aorta pumping that oxygenated blood out to the body. I quite like that animation. It took me ages to do. So let's now break it down a little bit slower. And then what you're actually going to be witnessing is what is called the cardiac cycle, which sounds complicated, but it is just blood moving through the heart. So it's just naming the parts of the heart in the right order for how blood moves around the heart. So we've seen the structure of the heart, all the components of the heart. We've seen how the heart contracts, the movement of blood through the heart, and we know what diastolic and systolic mean, and we know what the cardiac cycle is.